But okay, welcome everybody to this session. So we are going to talk about climate impact of software testing for next 30 minutes or so. Climate impact, so very important topic. We all want to do good things for climate, right? And now we have a chance. So with this talk, I hope to inspire all of you to take some steps that can be closer than you think. They can be quite natural steps to you. So let's go and see what do I have here. My background is man of many hats, like Sami introduced a little bit. Lots of awards, lots of books these days. As always, I have a few books of mine with me. Currently, I'm running trainings through my own company, Dragons Out, and I'm also quite active in many other fronts. So my book business, my training business, that's my own company, and this is what I love to do. I would like to mention that with the book, I want to have, you never heard the term, big, hairy, audacious goal. BHAG, anybody? That means really big goal. With that goal, that book, I have a goal that every teacher in the world can teach testing to their children through free materials that are out there. Anyway, I'll leave that thought with you. One of my hats is ISTQB. I'm very active on this international organization. I was also 6 years in the executive committee, so running this organization from Brussels. And another hat of position of trust at the moment is with the board of directors of Team MI, and this is run from UK. It's about test improvement in different ways. But that's my background. So now you know a little bit about me, and now next let's go and try to understand a little bit about this climate impact. And there's lots of terms coming up here: sustainability, green this and green that. Carbon footprint, carbon handprint as well, and so that's the agenda. We go towards more and more detail as we go. First, what's green ICT, information and communications technology? So to understand that, of course, we need to understand the background. So we know the climate is changing, it's warming. That's not a good thing. If it warms too much, we will have big trouble. One of the most visible signs will be that some animals, like the nice polar bear here, will not be able to exist at all if things go very, very bad. And to make this not happen, we world leaders have decided to have a limit of how much the climate can warm, and that would be 1.5 degrees from where we are today. Well, from where we were there many years ago. So today we are probably already like half a degree from that benchmark time, and so we need to have lots of things to do around climate. United Nations has declared climate action as one of the sustainable development goals. So climate is not the only thing, of course, that's sustainable. Or within sustainability, it's not the only thing. You can see there are 17 other goals that have to do with sustainability. Sustainable way of life, sustainable way of working, sustainable way of doing business. But it is, I think, the most important one, because that is really threatening the mankind as a race. So let's try to see what can we do. So within green ICT, that is everything that we can do in ICT to help. So it can be, of course, defined in many ways. You could say it's the study of practice of using computer resources efficiently and effectively with, and the point is, minimal or no impact to environment. So that's, I think, quite a good definition. Another one I actually like even more is from a Finnish author of a book called Green Code. He's saying, to combat climate change, all viable avenues must be explored, and the ICT industry must also play a role. And that's something that we maybe haven't thought about, because we are doing lots of good in ICT, right? So we still have a role to play, and we just need to find that role. To understand some of the terminology we use in next few slides, I put some definitions here to help you understand that. I think people have heard about footprint. That's all over the news and everything. So carbon footprint is, it means that anything we do, we also contribute to some carbon dioxide emissions to the atmosphere. So greenhouse gases in general, it's also methane, but it's also others. The talk is about CO2 mostly, but it's the others, we need to remember that. And so we all want to have as little carbon footprint as possible. So what is less known as a term is carbon handprint. And that means that while we try to improve our ways of working and have a smaller carbon footprint, we can actually go further than that. We can affect the climate positively. And that would be carbon handprint. So not the footprint, that's bad, but the handprint, that's good. So let's remember that. So from having carbon footprint, measuring how much that is, to minimizing how much that can be, and then in the end, going further, having a carbon handprint. For IT industry, and I have to say, I thought this as well. I was for years very happy being in ICT industry because I was thinking, like, we are the good guys. You know, we are helping others be greener. We are making paperless offices possible. You know, you don't have to cut so many trees and you know, use all that energy to move around some post or mail. It's all electronic, so it's good and it's better, right? So, and that's true, but it's not the whole truth, because we also are putting out some CO2 emissions as we use our software, as we create the software, as we test the software. And of course, it's great that ICT companies can help other companies to be greener. That's super, and that's really part of a handprint that ICT companies can do. But we also need to, you know, clean our own backyard, as they say. Otherwise, we are just using too much energy on our own, trying to make a good thing for somebody else. So let's help ourselves before or at the same time when we help the others. So that's green ICT, really, and when within that, of course, green testing. So testing is out there. We can also be green in testing, make some good choices. We cannot cure the world on our own. It needs to be all of us together, the whole world, all of the ICT industry. But testing, of course, has a few particular things that we can do. So first of all, we can, of course, help measure. That's what we do. We measure, we give feedback. That's the role of testing in general. And so we can also measure the climate impact or the level of sustainability that the software has. And then, of course, we can look at our own practices, our own testing practices, and try to make them greener, try to make them use less energy, because energy is really energy usage is what is making those CO2 emissions happen. So some different choices have been made. People have looked into the topic. Past few years, going in conferences, there's been 1 or 2 talks on these topics, but not too many. But I think people are getting the awareness and making actions as well. One of the early adopters of green testing, or sustainable testing as they call it, was Experimentus. So here I'm referring to their excellent material on this slide. So sustainable testing in their definition means that you optimize your resources, how much you use them, so try to minimize basically. You use test automation, because that does help already. It's faster. You optimize your performance testing in the same way. That's very energy consuming action, actually, if you run big tests, lots of users. You try to have early work, you know, shift left kind of work. So do early QA, do reviews, things like that. So that would be defect prevention. Environments themselves, can you choose if you can take a server that doesn't use so much energy over some very old, almost broken server that's just, you know, consuming energy like hell. When you choose your tests, can you use techniques that help you choose less tests? You can. And the final one is collaboration. So we work together, create awareness about the choices that can be done for better, greener choices, and you're going to be good. So that's kind of overview. I dive deeper into this in the next few slides. Also using some workshop I ran a bit more than a year ago, which has some interesting results. But let this be an overview of sustainable software testing. There's, by the way, a nice survey on the website if you want to know how green is your testing. So take a look at that. But okay, let's talk about the measurements. So how do we measure? Well, if you look at ways of measuring in general, it's about understanding what quality means to you. And to do that, it's good to understand different kinds of quality characteristics. And here as an example, I took ISO 25110 standard, which doesn't mention climate impact. It does, if you look at it carefully, you might see something a little bit like that, and that would be the performance efficiency. How efficient in performance is your software? But I would add, specifically, explicitly, that you need to think about climate impact too. So I would expand quality criteria. Another example, Richard Edgren's list of quality characteristics. There's one sub-area within area of compatibility there, and in his list it actually says sustainability, and it's talking about energy usage and all these things that we've been talking. So you could take that quality characteristic list and it would already have the sustainability. You wouldn't even need to add it. Or if you look at what Giorgetti is doing, they are actually also referring to ISO 25110, which actually does have, so in the previous slide you saw the internal quality characteristics. Here on the right side you see the quality in use in the same standard. But even that doesn't mention explicitly the sustainability or climate impact. So what Society has done is adding their own version of that standard and adding inequality in use part with sustainability part. So I think lots of companies are already doing it and adding this, and once you have that steps, you have added it into your considerations, it will happen naturally. That's how things roll. Think about quality when you test about that, measure about that, and it will happen to some extent. Let me make another example where how you can measure. This is a model I like quite much. I use it quite often. It's not a new model, but it does nicely emphasize that all the costs that you are getting because of bad quality could be avoided if you did things earlier, if you did things right the first time. Of course, it never happens that nicely. So you do have also costs on the bottom, so costs that happen because of defects. So prevention cost, appraisal, failure, external and internal. So that tends to happen. But let's look at it through the glasses of sustainability. So if we add some climate impact things there, on the prevention part, which is the cheapest way to make some effect, is the quality systems. So that would be your quality characteristics. So within there, you can add the climate impact. And how about appraisal? So appraisal normally would be testing. So you test on purpose to make sure there are no defect escaping to later and later in the process. Well, you can again add some tests that actually measure that climate impact. How much energy does your server use now that you have a new piece of software running there? And obviously, if you still find some defects, some of those will be found in your internal test. That would be the bottom left, failure cost internal. So also there, you can try to think about how much testing time you actually do. So it goes into optimizing your time use when you have a defect, and then again trying to minimize that. And finally, some of the costs related to bad quality are external. So some defect goes out into production, it's there, customers find it, there will be penalties. if we take sustainability glasses, some of those penalties will be climate sanctions, or you need to CO2 compensate because you are running these huge servers. So just take the sustainability glasses with you into the consideration of what to do, when, and how early, and how do we build the quality in. To give the practical advice, so the general advice was put the quality characteristic, sustainability or climate impact there somehow. So where should I put it? Well, many places. Definition are done. It's a natural place because it already says, do this testing, do that testing, do the documentation, use source code control, whatever, add sustainability there. Think about sustainability. It would be then in use all the time. Or when you do test planning, think about it there. When you do reviews, don't only look if the functionality is nice or if the performance is okay, also look at the sustainability. If it's implemented, does it use lots of energy? And obviously, when you code and test, you carry on using the sustainability glasses all the way through. So that's what can be done in practice. Okay, next section, we are going to talk about test environments. And this is a specific section because I think here, testing uses most energy. So this is maybe the easiest place where we can affect our own actions. When we test, we use energy. Can we somehow minimize that? So let's think about the environment from point of view of how early we test, how early we can find some of the defects. I was looking at a version of this Bohm curve. It's very famous. A version that would be fun, and so I chose this one because I used to skateboard myself when I was a teenager. So this is my favorite version of this fabulous picture. Bohm numbers, Barry Bohm's numbers have been there around for decades, and there's new studies that have always the same results, which is very straightforward. If you test early, if you find defects early, it will be so much cheaper than finding the same defects later and fixing them later. If we add the test environment idea around here, if you find defects late, that will mean you have used more time, you have used more test environments, you will have used also larger environments. And that obviously means bigger carbon footprint. So also from environment point of view, it's pretty bad to find defects late. So why don't we try to find them early? So if we find them early, it means the positive things. So we can use a smaller environment, do more tests on that development laptop, or in the first small test environment, we can do many tests there. We don't need to have a big environment to start with. And by choosing first a small environment, we use less energy. We have a smaller carbon footprint. So quite straightforward, very simple, I think. So I think, do things early makes sense from many points of view, including climate. Another aspect to test environments is, of course, the cloud. So how do we get the new environment up and running? So obviously we have virtualization, we have cloud, we have containers, etc., service architecture, FaaS these days, and all of these actions enable environments to be created on demand and quickly. So if we want to be wise, we want to put our environments into cloud in the same way as lots of the software these days runs. So we want to have test environments in shared machines in cloud using that shared space, which means again using less energy because less computers are needed. From point of view of how quickly we get those environment up, if we have good scripts, good deployment scripts, and we invest in that DevOps pipeline or CI/CD pipeline to get yet another environment up and running, again, we are saving time because we are not peddling around manually with environment setup. Or just in case we are not keeping a big system up and running, with test environment up and running, rather we run a script, we get it up and running when we need it, and then we can put it down, then we don't need that environment anymore. So let's use faster environment setup. Let's use those deployment scripts or create them. So if we put that together in a picture of DevOps or CI/CD pipeline, what would happen is that we can do more and more tests in more and more environments, but early on. And as we earlier talked, the earlier environments will be smaller, we will be using less energy, and because we are using it on demand, the total sum of energy usage per environment will be less, because we try to be efficient and test early with those environments. So faster feedback, in other words, means, again, good impact, smaller carbon footprint. And that's kind of the logic of that. And how about then minimizing carbon footprint of testing in general? So in this set of slides, I go a little bit deeper. So similar stuff that we heard about experimentuses, definition of sustainable testing. But these ones actually come from a nice workshop. There's this green ICT ecosystem in Finland, and they get together quite often. I've been part of those meetings a few times. And the first time I was there, I was invited to be the tester there to bring the testing perspective into green ICT. And together with like 20 or 25 people, we got excellent ideas, lots of good ideas. What we did was look at the value stream of a typical software creation value stream, like you can see there. And then we brainstormed how can we affect the quality and testing from sustainable point of view as early as we can in each of those steps. So here I will explain what we came up with. So first of all, product vision. So when you have a nice idea about a great product, already there, actually you can think about it. So a tester there would be asking a question like, okay, that's a nice vision, but could we do it differently? Could we actually choose to create a product that is already having a carbon handprint, for example? Or can we create a product? Okay, it's certainly needed. Can we make it so that it uses less energy? So we can ask these questions, and sustainability can be brought into the product vision. The product vision itself can be turned to the best possible format from point of view of sustainability or the climate impact, or energy efficiency as it says. So basically bringing in those quality characteristic discussions that I earlier mentioned. So this would be a place to do it, product vision already. So sustainable big picture, again, good results. So that's the idea. Talking a bit more on the next step, so what happens after product vision? Well, you do some requirements. You list a little bit, okay, I need this and that in my system, and that will be the product. So within that area, reviewing those requirements or collaborating in creating those requirements. Lots of discussions. Obviously, testers always have good things to do in those discussions, pointing out early quality, and if you do that, it will be lots of testing, also testability things. If you do it like that, it will be easier. So bringing the sustainability perspective into those discussions. So looking at any requirement, thinking not only through other quality criteria, but also through the sustainability criteria. And then you can actually make wise choices before you have any code. An example, the third bullet is a great one. So what if you would have a website that has some data coming from outside of the system? So for example, weather data. So if your website has weather data component and you want to implement that, typical coder would be probably implementing one script saying, fetch it from the weather forecast service. And that's fine. It would be easy to do. It would be there on your website, the same weather component. But actually, from energy point of view, what happens? What actually happens is that every time somebody comes onto that website, they would actually create a poll. It would be a dynamic polling. It would be a poll to that website somewhere else, that the weather service website, and the answer would come back to your website. That's fantastic. But what if it's done 10,000 times in an hour? What if your system is such? Wouldn't it be enough that your system statically polls the weather every, let's say, 10 minutes. It would be totally same for users, but from points of view of how much energy was used, 10 times per hour or 10,000 times per hour, which one uses less energy? Quite clear, right? But people don't think about this. So you can make these questions when you think about requirements of a software. All you need to do is have these glasses of sustainability with you, and then you can do these choices. So climate impact, obviously testability and test automation views are also good for climate impact, because if it's easy to test, if you can use test automation, it will use less energy. So you want to have good testability in your system that is being built. So that is kind of indirectly affecting, again, sustainability. So if you can achieve easier tests in the requirement phase, it will be, again, good results. Okay, next one is optimized test suite. And this means that when you design your tests, can you somehow design less tests and still have the same coverage? You actually can, and that's quite straightforward. You just use test case design techniques that are optimizing and minimizing number of tests that you need to get some coverage idea. And this would be new tests and later tests as well. AI, interestingly, helps here, can optimize quite a bit, and at the same time, AI uses a lot of energy, right? When you build an AI model, it uses a lot of energy, so it's a very difficult topic. But anyway, you can even think about that. So a big picture is less tests, good results. Obviously, the same thing happens when you execute tests. So when you have lots of automated tests, for example, it does matter which order you use them. So you can get the results quicker if you know which tests to run first. And then actually you don't need to run the other tests, at least not all the time. So again, it means less tests. It means also more smart tests, and it means, again, good results. Okay, and in general, that does mean automation. So if you use automation, you will be doing quicker tests, and that will mean good results as well. Here's a problem also, of course. So if you do too many test automation, we have a new environments, we have test automation scripts, we can do as many tests as we like. There's a challenge where, of course, you don't want to overdo your test automation. So even if I'm saying now here, use test automation, I'm at the same time saying minimize the number of tests you run. So you need to keep in mind with both things, and you find the optimal trade-off somewhere. Finally, there's monitoring in production, and this means that, as in all testing, you can also get more feedback from production than your customers are using your software. And the climate view here is that if you understand how we are using it, you can optimize your software so the testing can give it to the development who can make the software even more energy efficient. Or you can even switch off some parts of software that nobody seems to be using. That would be even better. Smaller software is better. So you monitor, and again, good things happen. In between the lines, there has been agile and DevOps, and these are good trends for climate point of view, because you are doing things early. You have the early quality, and that from environment point of view, as you remember, it means using less energy. So these are good things to adopt from climate point of view as well. So what's next? And go into the final slides and then some question. Learn more. Try to understand how your testing is in relation to the green or sustainable aspects. Luckily, lots of the good things that make sense from testing point of view anyway are also good for climate, so adopt those. So agile, DevOps, earliness, optimization, and automation. And here are some links for you. I will actually share the materials on my LinkedIn profile pretty much after this session, so you can connect to my LinkedIn and get the PDF from there very quickly. So right now, any questions? Thank you.
Thank you, Kari. And yes, actually, we have now time for 2 questions. Who is the first one?
Thank you for this presentation. I wonder what would be your advice in approaching green testing in legacy applications when something, the infrastructure, servers, the methodologies of how to do things, developing code and testing has been there for like, I don't know, 20 years and so on. Mm-hmm. How do you kind of give the momentum to green testing and start moving?
So if your infrastructure is from 20 years ago?
Well, more like the way of setup is like, let's say, a monolithic application uses like cloud, like big servers, and they're not willing like easily to move to something greener and more sustainable. How do you do the persuasion, I guess, and just come up with a plan?
Okay, so on a move to modern technology, infrastructure or software itself, it's not as straightforward as let's go to the new environment, go to new infrastructure, on-demand infrastructure. That would be a too easy choice. Going there, you can also spend more energy. So actually what you would need to do is whatever your choices are, try to be as early as possible and try to measure those things that you are doing. So you can actually measure with some software how much energy your choices are using. So there are small bits of software, but also free software that you can use for that. And if you have old infrastructure, it's not necessarily bad, but usually the old infrastructure runs in a big server, and that consumes huge amount of energy. So I would say the general advice is to move to newer ones anyway. I hope that answered a little bit what you asked. Okay, thank you. Another one.
No questions, actually. I would like to ask one thing. As much as I see, the scope of testing is going bigger and bigger.
It does.
And what do you think, how much time and money should be added to the testing budgets to also cover this sustainability topic?
Well, I think optimally it doesn't take any more time, because it's just that another thought in your head when you do those choices. How much automation I do? Maybe I do less automation. How much tests I create with my techniques? Maybe I choose one technique over another technique because it results in less tests. So it doesn't need to take more time. I think that's how we should try to approach it. In the end, it might take more time because we are measuring something else, and maybe we run that another component that is actually measuring the CO2 emissions per component running every minute. So yeah, maybe a little bit, but I would like to look at it optimally and optimistically that it doesn't take any extra budget.
Thank you. And now please give a big round of applause to Kari.
Thank you.
And also for you, a small present.
Wow. Thank you very much.
So please don't eat it alone, so share it with your relatives.
Absolutely. Thank you.
Thank you.